Okay, dear students, let us now have a discussion on our next topic, which is of center of gravity and centroid. Okay, so centroid is a center of area is or center of area is defined as the point where the whole area of the figure is assumed to be concentrated. So this is in simple words a definition of the centroid, and ma- with the example of few figures we will understand what does this mean. Say for this entity of a rectangle entity, you have area of the rectangle to be b into h, where b is the breadth and h is the height, and its distance, the distance of the centroid, which we notate with the help of x bar and y bar with the help of these symbols. In x direction, it is if we take this corner, lower left corner, as the origin, then b by 2 along the x direction and h by 2 on the y direction. Okay, these are the this is a point where the centroid of the rectangle will lie. Similarly, for example, for a triangle, you have an area of BH divided by 2, and the centroid, the position of the centroid will be B by 3 and H by 3, taking into account this left lower left corner of this triangle as the origin. And similarly, for a circle, again, this is the center point of the circle, so which we can we area of a circle we already know, pi by 4 d square, and d by 2 is the x position and y position of this centroid. And this is pretty simple for a circle, but for a semicircle, you have a different location of this centroid. The area is notably pi by 8, so because it is half of the that of a circle, so pi by 8 d square, and the location of the centroid is d by 2 along the x direction, and 4 r divided by 3 pi, which comes out to be 0.424 r along the y direction. Because for the center it was pretty simple, in both x and y it is at a distance of d by 2, but here it is because it is a semicircle, the location is somewhat above this 0 0 position. Okay, so which is given by 4r divided by 3 pi. So for a quadrant circle, that is 1/4 of a circle, the area comes out to be pi by 16, because 1/4 of a circle, pi by 16 d square, and the x location and y location are both 0, which is again 4 by 4 r divided by 3 pi, equal to 4 by 3 pi. So this is 0.424 r. Okay, both along x as well as along y direction. And for trapezium, um, uh, with two sides, one side is A and another is B, and the perpendicular distance being h. The area is A plus B into h by 2, and the distance, that means the location of the centroid from the lower left corner, is a square plus b square plus ab divided by 3 into a plus b, and along the y direction it is 2a plus b divided by a plus b into h by 3. So all these notations, the locations of the centroid, we can easily find out using a methodology or procedure that we will discuss later. But this is at this point of time you can remember all these. And For irregular bodies, not irregular, but which are a combination of some regular bodies, also we will discuss in the later section. Now here, position of centroid of gravity of regular solids. Again, we will talk of cylinder, sphere, and some regular bodies like hemisphere. Mm. For cylinder, the volume is pi r square into h. Okay, and if we are particularly talking about the weight, so this is pi r square h into rho, or rho. We can give this symbol as take this symbol as rho, or sometimes as w, which is nothing but the weight per unit volume. Okay, so because the volume we know, in case of the density of the solid is uniform throughout, so we can simply multiply it with the weight per unit volume. Okay, pi r square at h into w. Say w is the weight per unit. So we are discussing the volume only here. So this is the location, as you are. You can very well find out seeing this figure of a cylinder. It is at the center point, as well as center point in both in the x y direction as well as in the vertical direction. So sphere, it is volume we already know, 4 by 3 pi r cube, and the center point of the sphere is the centroid. For hemisphere, it is the volume is half of the full sphere, which means 2 by 3 pi r cube, and the position of the centroid is center for x and in the plane, xy plane, and in the z direction it is 3 by 8 into r. Okay, and for right circular cone, it is the volume is 1 by 3 pi r square into h, and the location is h by 4 from the bottom center of the this plane, cone, base of the cone. Okay, so this is in brief the introduction of the center of area, or centered of area, and centered of some solid bodies. Um and in the next video, we will discuss about the centers of composite areas.